Hi guys, my name is Peter and welcome to a new video. So in this video we are gonna learn about Kubernetes. So just like any of my other video, this is gonna be a hands-on video because I really believe that if you want to learn something in detail, practicing it in a practical way is the way to go. So in this video we will be deploying an application to Kubernetes cluster, and by doing that we are going to learn about all the different concepts of Kubernetes. So guys, before moving on to the video, I just want to give you guys a high level overview of what is Kubernetes and why do we even need to use it. So if you don't know, Kubernetes was actually called as Borg, B-O-R-G, and it was actually developed by Google and they were using it internally for a long period of time, after which they open sourced it under CNCF, and that is why right now we all of us are using Kubernetes. So in simple terms, Kubernetes is a container orchestration platform. Now you might think, why do we even need to use Kubernetes? So now if you observe almost all organizations around you, you can see that most companies are going forward with microservices based architecture, which means that the entire application or software is divided into multiple chunks, and each of these chunks is called as a microservice. And when it comes to deploying these microservice, each of these microservice will be a container. Now you can imagine that for a large organization there will be hundreds or even thousands of containers, and these containers are not simple, they are extremely complex because these containers talk to each other, they share data, and there can be situations in which these containers can go down. So in those kind of scenarios it is really difficult to find the root cause and then to fix it. And that is when container orchestration platforms like Kubernetes and Docker Swarm comes into the picture. But out of it all, Kubernetes is the most popular one. Now let me give you guys a real life analogy of Kubernetes so that you can understand it in a better way. Imagine that you went to an event and there are 5 different food stalls serving food, and then there is a manager who is overseeing all these 5 different food stalls. So if there is a shortage or if there is an issue, he's going to get involved and fix the issue. Kubernetes is pretty much similar to that. So Kubernetes is gonna oversee all the different pods running in the cluster. So if anything is gonna happen bad with any pod, it is gonna get into action and Kubernetes fixes the issue. So that is what Kubernetes is in a really high level overview. So I believe that most of you guys have already learned about Docker, right? So maybe if you are determined enough, it actually took a couple of days for you to understand Docker maybe in detail. But Kubernetes is not really like that. It is a much more complex topic and takes a lot more time and patience to understand it in detail. And at times you might also need to go down the rabbit hole to understand it in a much better way. So what I'm trying to convey is that even if you don't understand things in a much detailed way, don't worry, it takes time. But I'll try my best to simplify things in a much easier way to understand. So before moving on to the video, to follow along you need to have 3 main requirements. The first one is Docker. So you need to have Docker installed on your machine. You can simply search for Docker and install Docker desktop. So if you are using a virtual machine, you can simply install Docker engine and you will be good to go. And the second requirement is nothing but it is kubectl. So kubectl is a command line tool that helps us to interact with the Kubernetes cluster. So in this particular page you can click on get started, and if you scroll down you can see download and install tools including kubectl. Just click on that. So here you need to select your operating system. So if you are on Linux, click on that, and if you scroll down here you can see a 4-step process to install kubectl. So once that is done, scroll all the way down in the same very page and click on install minikube. So what is minikube? So minikube is nothing but it is a cluster. It is nothing but it actually simulates a cluster for us on our local machine with a single node. So unlike a managed Kubernetes cluster like AKS or EKS, minikube is a really good start for beginners or learners to play around things, break things and all. But In case of a managed Kubernetes service like AKS, it is going to cost a lot of money, and it is not that easy to set up AKS as well, because it requires a dedicated video of its own. So that is why I think that for a beginner, Minikube is the best way to play around, because it is pretty much similar. Once you understand Minikube and how things work, you can replicate the same in a real life environment in AKS, CKS, or the same in GCP as well. So here you can select your operating system configuration and run these two commands right over here, and finally you can type in minikube start to start the cluster. But before running this particular command, make sure that you are having your Docker engine running. So that's it. These are all the requirements that you guys need, and now we are good to go. So here you can see that my minikube is running right over here, and this is my Docker desktop. Minikube image, the minikube container is all set and running. So here you can see that this is the Kubernetes architecture. So we will not be discussing it right now because it is kind of complex, but we are going to come back to the architecture once we finish the demo, and at that point I think you guys will understand it in a much better way. So this is the architecture of the application that we are going to deploy. So you can see that we will be deploying a simple React application. So here you can see that I have already created a sample project. So it is nothing but it is a simple React project. So we are going to deploy that. So if you want to see it, let me enter npm start so you guys can get an idea of how it actually looks. So this is the application. So it is a default template. I haven't made any changes. All right. Just a second. Let me arrange the windows. So let's kill the terminal. All right. So let us move to the first step. So as I said before, the first step towards deploying an application into a Kubernetes cluster is containerizing the application, right? Because containers are what is being deployed into the cluster. So this application is not yet containerized. Now let's do that. So in the root directory, I'm going to create a Docker file. So I won't be going in detail regarding what is a Docker file or how we can write a Docker file, because I believe that most of you guys might already know about it. So I'm going to simply copy and paste my Docker file for this particular application, but I'm going to explain it step by step as well. And I'm going to paste it right over here. So now let me spend some time to explain what this Docker file is. So if you give a second and look at this Docker file, you can say that this is a multi-stage Docker file. So now you might think, what is the difference between a multi-stage and a single stage? So multi-stage Docker file can help us reduce the container size image to a great extent. So you might think that why do we even need to reduce the container size image? Because anyway we are going to pull the image from somewhere and we are going to deploy it. So that's it, right? But in a real life scenario, if you are working in an organization, your image, that is your image, will be stored on some kind of private registry such as ACR, that is Azure Container Registry. So by default, this kind of a private registry will offer only 10 GB of storage in case of Azure, and anything above that you need to pay additional amount or additional cost. You will incur additional cost. So in that kind of a scenario, it is extremely important to optimize your container image to as minimal as possible. So that is why we went here with a multi-stage Docker file. So let me explain what it is. So first of all, we are importing an image. So this is nothing but this is a node image, but the Alpine version of it, which means that this is going to be lightweight and will contain only the necessary tools and packages that are required for this particular operation. And here you can see an as build tag. So this particular first stage is named as the build stage. So this is the name of the stage. So the moment this particular command is being executed, you'll be having a virtual machine. Now whatever command that you are going to run after this particular line will be executed inside that virtual machine. So here you can see that here running a couple of lines. So first of all, we are changing the directory of that virtual machine to /home/app. So right now we are inside the app directory of our virtual machine, and now we are copying all the files from source to destination. So the first dot is source, So the first dot indicates all these different files right over here, and the second dot indicates the app directory, because we are currently in the app directory, right? So it simply indicates copy all the files in the current directory, which is all these things, into the current directory of my virtual machine, which is app. So after running this particular command, you'll be having all these files inside the app directory of the virtual machine. Then you run the command npm install. So it is going to install all the necessary packages from package.json file, and then we are gonna run the build command. So the build command is gonna package the application into a compact size. So after this particular command is being run, we'll be having a build folder inside the app directory. So that is done. Now comes the second stage. In the second stage, we are importing the nginx image, and into the nginx image we are copying something. So here you can see the copy command, and we are copying it from the previous stage, which is the build stage, and from the build stage we need to provide the source and the destination. So the source is nothing but it is the build folder which we created as a result of the first stage from the app directory, and we are copying the build folder into the HTML folder of the nginx. Pretty simple, right? So that is what is happening in the second stage. So in the second stage, the cool thing is that if you don't have a second stage like this, you'll be having all these files from npm install, because we need not need all the files. We just need a build files to run the application. So what is a container? A container is nothing but it constitutes the necessary packages to run the application, right? So the build file will be having those necessary packages, and we are just simply deploying the build image onto nginx, which makes the overall container image to a very minimal size. So I can show you that. So if I go to hub.docker.com, you can actually see the image, because I have already pushed this particular image into a Docker Hub. So this is the image right over here. So if I click on tags, you can see that the size is pretty small. It is almost 67 megabytes. So if you don't really use multi-stage, this would be over 100 megabytes. So you can even customize this so that it would be less than this particular size as well. But anyways, this is our Docker file, and I hope that you guys understood what it is. And we are exposing our application, that is, we are exposing our container to port 80. So I'm not really gonna run this particular Docker file, because I already have the image right over here. But if you want to run it, you can simply go for docker build -t, which is nothing but a tag. Then you need to provide the name of your Docker Hub account, and then after slash you need to provide a name for this particular container, for example test-app, and if needed you can provide a version like this. Or even if you don't provide a version, then it is gonna assume that it is the latest version. Then provide a space and then specify where is your Docker file. If you are in the root folder, you can simply specify dot, and that's it. Your Docker file will be built. And once your Docker file is built, you can simply type in the command docker run followed by the username / the container name, and your Docker image will be up and running. And another thing that I want to tell you guys is that if you are going to push this particular image into Docker Hub, just like that I did, then you need to add a docker ignore file, just like git ignore. See, if you are pushing the code to GitHub, all these files will be ignored. Just like that, you need to ignore the / node modules file, this one right over here, being pushed into Docker Hub as well. So you can simply add a docker ignore file and do the same thing. So that's it. Alright, now we are done with the Docker part. That is the first stage, that is to containerize our application. And now we are going to get on to the main part, that is the Kubernetes one. So here in the root directory, I want to create a folder called as Kubernetes. Alright. Yeah, now we are going to get into business. So before that, let us make sure that we are in the Kubernetes folder. Yeah, we are in the Kubernetes folder. And also let's verify that minikube is actually set as our current context. So for that, let's enter kubectl config current -context. So you can see that minikube is our current context. So if I enter kubectl get namespace, you can see that we are having all the namespace right over here. And another cool thing is that by default Minikube also installs Kubernetes dashboard, so you can see things visually as well. Now if I enter kubectl get pods, you can see that there is nothing, no pods are running. So our first step is to create a pod. So here you can see on our image, you can see that inside the pod we are having the container, which is a React application, right? So our first step is to create a pod. So let us search for Kubernetes pod, and let us go to the official documentation of Kubernetes. And if you take a look at the definition, pods are smallest deployable units of computing that you can create and manage in Kubernetes. So in simple terms, a container will be running inside a pod, and it is the smallest deployable unit of Kubernetes. So if we scroll down, you can see the file right over here. I'll copy it, then I'm gonna explain it to you guys. So inside the Kubernetes folder, I'm gonna create a file called as pod.yaml. Alright, so let me close the terminal and let us paste the code right over here. So it is a pretty simple one. So you can see that we are specifying the API version. The type of or the kind of file that we are creating is a pod, and here you can provide the name for this particular pod. So I'm gonna name it as react-app. Let me copy it. And the spec is the main part. Here is where you are specifying the details of the container. So first of all, you need to provide a name for this particular container. So I'm going to name it as React app, and then you need to provide the path to the image. So let me delete it. So as I already said, I have pushed my image into Docker Hub, so I can simply copy it from here, and I'm going to paste it right over here. And I need to remove the Docker pull command, so I'm going to remove that. So here, whenever this particular file is going to be executed, Kubernetes is going to go to this particular location and fetch this particular image. And I'm going to save it, and I'm going to leave the container port as 80 because the Docker container is running in 80. So I want the pod to run in port 80 as well. That's it. So I hope that you guys understood what it is. So naming convention is pretty important because later when we come with the services, we'll be using labels and selectors. So it is always better to follow a consistent naming convention throughout the cluster. So here, let's open up the terminal. Let me clear it. So now we need to make this pod live. So we're going to run the command kubectl apply -f, then the name of the file, which is pod.yaml. And now you can see that pod/react-app is created. So now we have created this particular pod in the default namespace. So if I enter kubectl get pod, you can see that our React app is currently running. So what is a namespace? Because I already show you guys what are the different namespaces. So these are the different namespaces. So the currently our pod is running in the default namespace. So a namespace is nothing but it is a confined environment. So in a large scale application, you will be having different namespace for different parameters. Like for int, you will be having a separate namespace. For QA, we will be having a separate namespace. So things are confined in their own environment. But since this is a demo, I don't think that we need to create a separate namespace. You can deploy the application in default, or else if you want, you can also create a namespace as well. In that case, when you apply your file, you need to provide the tag -n and your namespace name. That's it. It's pretty simple. So now we are having our pod running. So let's also enter kubectl get pod. So you can either enter PO or you can also enter pod. It specifies or signifies the same thing. And if you enter dash or white, you can get much more information about the pod. You can see that the name is React app. There is only a single pod running. The current status is running. This is the IP. The node is Minikube, and all those details are right over here. Alright, now we are having the pod. So if you need to access this particular pod, we can, if you are assigned into the master node, you can simply curl and find it. We are not going to do that because later we will be using services to access the pod. So I'll leave that for later. So there is actually a major drawback with creating a pod this way, that is with the kind of pod, because we are lacking two major features, that is auto scaling and auto healing. So let's imagine that this pod got deleted. That's it. Your application will be down. So let's imagine that it is one Friday evening, everyone is at home enjoying their weekend, and in the middle of the night, that is at 1 a.m., this particular pod, that is the React app pod, got deleted somehow. That's it, your application is down. None of your end users will be able to access your application. Let's simulate that. So if I enter kubectl delete pod react dash app, you can see that pod react app deleted. Now if I enter the get pod command, you can see that there is no pod running. So this can be a pretty dangerous situation when we look at a highly available architecture based system, and that is when deployment files comes into the picture. So the deployment files are pretty similar to this particular file right over here, but we are having a really important superpower called as replica sets. So a replica set is nothing but you can specify a number in the replica set, and Kubernetes will always monitor your pod and make sure that the number that you have specified in the replica set will be always maintained, and that is called as the desired state. For example, if you specify 1 in the replica set, what happens even if your pod got deleted, that count becomes 0, right? Then Kubernetes is gonna check is the replica set's desired state is being met. If it is 0, then it is not met, then Kubernetes is automatically going to create a pod. I'll show you guys with a demo, then you'll understand it in a much better way. So now let's do that. So for that, I'm going to search for Kubernetes deployment. Let's open up the file right over here, the first link. So if we take a look at the definition, a deployment provides declarative updates for pods and replica set. You describe a desired state in deployment, and the deployment controller changes the actual state to the desired state at a controlled rate. So this is the cool thing about having a deployment file. Your desired state will be always maintained. Whatever happens if the pod got deleted, in any of those scenarios, the desired state will be always maintained. So I'll show you guys, then things will be much more clear. So first of all, let's copy this particular file from here, and here I'm going to create a new file called as deployment.yaml, and I'm going to paste it right over here. So it is pretty similar to our pod.yaml file. So the main differences are the kind is deployment, and then you are having the metadata. So I'm going to name it as react-app. Let me copy it. So the label, I'm going to remove the label for now because we don't need it. So now comes the spec. This is the cool part, the replica set. So let the replica set remain as 3. So what it means is that 3 pods will be created. So if I have 5 pods will be created, and that would be the desired state, right? So I think to make things clear, let's start with 1 and then I'll show you guys how it is. Now comes the selector part. So selector is pretty important because in the next stage, so this is stage number 2, that is creating the deployment file. So in stage number 3, we'll be creating the service file. In that case, this particular selector is going to come in handy. So I'm going to name the selector as the same as the deployment file, that is react-app. Then we are having the template right over here. Again, I'm going to name it as react-app. And then we are having the container. So I'm going to not waste time explaining this because I already explained it in the pod section. So I think let us name it as react app, and let us copy the image, container image path from here and paste it right over here. Alright, let me close this particular file so things are much more clean. Now, so I hope that you guys understood the file. It is pretty simple and self-explanatory, just like the pod.yaml file, and the container is going to run in port number 80. So let us apply our deployment file. So let's enter kubectl apply -f deployment.yaml. So the deployment file has been created. So if I enter kubectl get pods, you can see that our React dash app pod is currently running, and we are also having an identifier because there will be more than one pod that might be created. So if there are 5 pods, we need to have some kind of way to differentiate them, right? So that is why Kubernetes is automatically adding an identifier right over here. But in the case of pod, you might have observed that there's just the name of the pod only, but here we are having an identifier to uniquely identify a pod as well. Alright, now this particular pod is running. So let us simulate the same environment, right? It is a Friday evening and something happened bad and your pod got deleted. Let us see what is going to happen in this particular case. So I'm going to run a kubectl delete pod, and let me copy it from here, and I'm going to paste it right over here, and I'm going to run it. Pod got deleted. Now if I run the get pod command again, you can see that again the pod is automatically being created again. So this is not the previous pod. If you take a look at the identifier, you can see that they are different. They're completely different, because the moment the pod got deleted, which is right over here, Kubernetes know that the replica set is 1, the desired state is 1. When this got deleted, the state becomes 0. Then Kubernetes got in and created another pod right over here, thus maintaining the desired state. And this is a huge deal when you are dealing with a high available architecture, to have the pod create its own, and which is all thanks to the deployment file and the replica controller. So this is called as the controller. So what happens is that you create a deployment file. Once a deployment file is created, a replica set is defined. The replica controller is what is going to create the pod. So the replica controller creates a number of pods. So let us change this to 5 and run the file again. So I'm going to run kubectl apply -f deployment.yaml. So if clear it and enter kubectl get pod, you can see that now 5 of them have been created. 5 pods are done. So the reason of having a 5 pod or more than one pod is to manage traffic as well. So like if you are having a service, I'm not going to go into the details because that will become out of scope. So when you create a service also can act as a load balancer. So that service can distribute traffic to all these different pods as well. So in that case, having a more than one pod can help the application perform really well in high stress situations as well. So don't worry if you don't understand that, because we will be discussing that later, or in this video, or either in another video, like how services can be created, more details into services, and how services can do load balancing even without a load balancer. We will be discussing all those things in some other video. But I hope that till now you guys understood how to create a pod, why should we not create a pod and create a deployment file, how things work out when things fail, and I hope that you guys got an idea. So now that's it. So we have created a deployment file, we deployed our pods into the cluster, things are fine. Now we need to access our deployment or access our application, right? So now comes the question, how we can access the application, and that is when services comes into the picture. So services is a Kubernetes feature that helps us to expose our application, and there are mainly 3 types of services. The first one is cluster IP, the second one is node pod, and the third one is load balancer. So if I enter kubectl get pod, you can see that -o wide, you can see that there is an IP right over here. So this is the IP that is being automatically assigned by Minikube. But this IP can be only used for internal communication, just like cluster IP. This IP can be used only for in-cluster communication, that is one pod can communicate with other pod. So that's the use with this particular IP. But if you want to expose the application to the outside world, that is when services comes into the picture. Like not just service, node pod or load balancer. These are there are 3 service type: cluster IP, node pod, load balancer. But node pod and load balancer helps us expose the application to the outside world. So if you take a look at the diagram right over here, you can see that this is the application, and we need some way for this particular application to be accessible outside the cluster, right? So there will be people accessing the website or the application from browsers, mobile phones and all other sources. So they need to securely access the application. So that is why we use a service. So now let's see how we can do that. So for that I'm going to search for Kubernetes service, and we will be making use of node port, but I'll be also explaining about a load balancer as well. So let's open the service. So if you read the definition, you can see that in Kubernetes, a service is a method for exposing a network application that is running as one or more pod in your cluster. So in simple terms, a service can help you to expose your application to the outside world, and what we are going to use is nothing but it is called node port. Alright, so if you scroll down, yeah, this is the YAML file for a service. So let's copy it and I'll explain it as we proceed. So I'm going to create a new file called as service .yaml, and I'm going to paste it right over here. So let us remove all these comments. Alright, now we are having a clean service file, and I'm going to explain it in a step-by-step manner. Alright, so here you can see that the kind is service right over here. So the name is my-service, so I'm going to leave it as it is. And here is the cool part. So what kind of service am I creating? So here I'm going to create a node port based service because I want my application to be accessible outside the world. So I'm going to go for a node port service. And the selector. So selector is a key part. So here when you create a service, the selector is going to look for the port that it want to expose. So that is why I said that here this selector is pretty important. So the way a service is going to work is that it's going to use labels and selectors. When you specify a particular selector right over here, when this particular file is going to get executed, the service is going to search for that particular pod, that particular selector, and that pod is what is going to get exposed, right? I hope you guys got it. So here I'm gonna specify the app as react-app because that is a selector that we gave. So if there is any typo, things are not gonna work. So you need to be careful with the naming convention, and also make sure that you don't make any typo while specifying the selector. So that's it. That is pretty much it. It is pretty simple. If you have paid attention to how you created the pod.yaml file, then all these things is a cakewalk for you. So here we specify the ports. So this is cool. We are having port, target port and node port. So these are three different ports that we are specifying. So the first port right here is the port of the service. So I'll explain it with the diagram. So you can see that there are three different ports. So the symbol port is nothing but it is a port of the service, which is 80 right over here, and that 80 goes right over here. And the second one is target port. So whenever a traffic reaches this particular SVC, where should I forward, or where should SVC forward the traffic to? Which is the target port that SVC should forward the traffic to? So that is the meaning of the target port, and the target port is 80 here as well, which is nothing but it is the port of our pod, right? So in the deployment file we specified the container port as 80, right? So that is why we are having 80. So whenever traffic comes over to SVC, so SVC is being accessed by port 80. When traffic reaches here, SVC is going to forward the traffic to the target port, which is port 80. Now what is the node port? So node port, the value of node port starts from 30,007 and it ranges to somewhere around 32,000. I don't exactly remember what is the range, but it starts from 30,007. So node port is the value right over here. So the 30,007 is the node port value. So the external world is going to access the node port via this particular port. The traffic reaches here, and that traffic in node port we specify the port for the service. So it is going to forward that traffic to the service right over here, and in service we specify the target port of our pod or the application, and that goes right over here. So that is how the entire data flow works, and I hope that you guys got it. So that's it. It's pretty simple. Now if I save it and if I apply our service, that is kubectl apply -f service.yaml, you can see that service slash my service has been created. Now if I enter kubectl get svc, we can see that the first one right over here is the Kubernetes default one, but the second one is the one that we have created, that is my service. The type is node port and we are having a cluster IP. So whatever the case, if it is a node port or load balancer, by default you'll be having a cluster IP. So this cluster IP is only used for internal communication. But if you take a look at the port, you can see that 80 and 3007, this is the node port. So that is how things are created. So now let us try to access this particular application. So I'm going to enter minikube service, then the name of my service, which is my dash service. Alright, so now what is happening is that we are having a React application right over here. So this is if you take a look at the URL, it is 127.0.0.1, which is nothing but it is a local host URL, and we are accessing it at a random port. So what happened here is that when you run this particular command, you can see the IP right over here. So this is the minikube IP and this is the port. So here we are nothing but we are creating a tunnel to access this particular application via our local host. So if I copy this particular ID right over here and enter localhost and paste it, you can see that we are still accessing the same application. And if I enter Control C, please take a look at this particular IP. If I enter minikube IP, you can see that this is the same exact IP. We are trying to access 3007, which is nothing but this particular node port, and that traffic goes to SVC and then to React application. So I hope that you guys got the idea. So this is nothing but this is a way of port forwarding so that we can access our application from our local machine. So that's it. Now I hope that you guys learned how to access a deployed application on your cluster, right? So it's pretty cool. So if I enter Kubernetes minikube dashboard, you can see that this is the dashboard, because I already showed you guys, right? If I hope that you guys remember, under the namespace we are already having Kubernetes dashboard pre-installed. So if you're working with a managed Kubernetes service like AKS, you need to manually install that. You can simply search for Kubernetes dashboard, go to the first link from Kubernetes, and you can simply run this particular command right over here to install Kubernetes dashboard, and you'll be getting something like this. So here you can see all the namespaces. We have deployed our application the default namespace. So if I go to deployments, you can see that our React app is currently running. 5 out of 5 pod is running. So if you remember, I told you guys there are 2 features with deployment, right? One is auto healing, which I already showed you guys. When a pod got deleted, it is automatically created to maintain the state. The second one is auto scaling or scalability. So if I click on the 3 dots, I can scale the number of replicas from right here as well. I can enter 10, and if I enter scale, you can see that now it is going to become 10 out of 10. And if I go to pods, you can see 10 different pods running right over here, right? So even if I delete one of that, immediately another one will be created. You can see that. So that is how the entire thing works. So let me delete it once more. You can see that another one has been created. This one is terminating, another one is already being created. So that's how beautifully things are going to work, and that is the beauty of having a container orchestration platform like Kubernetes. It is much more easier to manage all these different pods. You can just imagine the scale at which a large organization would work with hundreds and thousands of pods, containers, and all these things. It is a Herculean task to manage that kind of a scale without a container orchestration platform. Now I hope that you guys get the scale at which we are working, right? So I hope that that's it for the entire demo. I think that I went through most part of Kubernetes, at least high level overview. There are a lot more things like config files, secrets, stateful set, a lot of other concepts, but All of that is a separate topic, but this what we learned today is the basic foundation of Kubernetes, or how things are created. Now we can build upon this particular foundation and learn about a more complex topic like stateful set, which is used for databases, and all the other concepts like ingress, load balancer, and all these other stuff. So while we are here, let me also talk about load balancer. So as I said before, there are three service type: cluster IP, node port, and load balancer. So if you want a load balancer, you can simply replace here with load balancer. And what happens is that when you execute this particular file, your cloud service provider will allocate you with a load balancer. We can't simulate right here in Minikube because it is a local environment. But in real life, when you are working with a managed Kubernetes cluster like AKS or EKS, when you run this particular command, AWS or Azure or GCP is going to automatically provision you a load balancer in the backend, and also will provide you with a public IP address through which you can access your application. I hope that you guys got it. So we are not going to do that in this particular video, maybe in a future video. So to get those kind of information, make sure that you guys subscribe to the channel. And if you like what I do, or if you understand what I taught till now, please do consider liking the video as well, so that it can reach to more audience. So now, as I said, now let's go and take a look at our architecture and conclude the video. So now I think that you guys can understand this in a much better way. So you can see that kubectl. So kubectl is the command line tool that we use to interact with the Kubernetes cluster. So the Kubernetes cluster has two main components. It is the control plane and the worker node. So the worker node is nothing but it is a virtual machine in which your application will be deployed or application will be running. So there can be multiple nodes, more than one nodes. So as your application keeps on building, or when the traffic to your application becomes significant, you increase the number of node to support the application. So now let's simply track the flow of data. So let's imagine that you ran the command kubectl apply -f deployment.yaml. What is happening in the background? What is happening in the backend? Let's imagine that. So the command is going to reach to Kube API server. So Kube API server is the point in which we interact with. Any command that you write, or any CI/CD system, or any SDKs, they are all interacting with Kube API server. So the first thing that the Kube API server is going to do is authentication and authorization. It is going to make sure that the person who is trying to connect or make changes to the cluster is an authenticated and authorized personnel. So once the authentication completes, you can see all these arrows going up and down. I'll be not going into detail, but I'll give a high level overview. So etcd is nothing but it is a distributed database. It's also considered as the brain. So it is going to store the state of the cluster. And here we are having the kube scheduler. So kube scheduler plays a vital role. So here we have entered the deployment.yaml apply command, right? So kube scheduler, what it is going to do is that so the deployment file has got a pod to deploy, and that pod has got a requirement, right? So each pod will be having different requirement. Like some pod will be having a high memory requirement, which is basically dependent on the application. Some pod will have less memory requirement. So what kube scheduler is going to do is that it is going to go to this particular node, or the number of nodes that are there. So let's imagine that there are 5 nodes. So kube scheduler is going to go to each of this node and going to compare the requirement of the pod and the requirement that the node has. So if the node has the resources, that is the memory and the computational power to accommodate the pod, then the kube scheduler is going to assign the pod to be deployed in that particular node. I hope that you guys got it. So it uses a system called as filtering and scoring. It is going to filter the node based upon the compute resources required for the pod, and then it is going to assign one. So if 5 of the node is capable of deploying on the pod, then a random node will be selected. So once the node has been selected, kube scheduler is going to mention that to kube API server. See kube API server, node number 1 is capable of holding or deploying this particular pod. You can deploy that there. And now what kube API server is going to do is that it is going to contact the kubelet of that particular node, that is node 1, and it is going to tell kubelet that hey dude, install this particular pod, you are capable of doing that. And then kubelet is gonna use container runtime interface, that is CRI, like a Docker or CRI-o, to pull the image from the registry and gonna run it. And thus you'll be having an application running in a worker node. So proxy is what connects the entire thing together. It is the network part which helps the communication, the discovery and all these things, that is done by kubeproxy. So here you can see that CI/CD systems can also communicate with Kube API server. So in a real life scenario, personally I use Azure DevOps. So in that case, the CI/CD pipeline is what is gonna manipulate the cluster. So on behalf of me, the CI/CD system will access the given Kube API server, and SDKs can also access the server. Like if you're having a Python application or any sort of backend application running, so you can use the SDKs to access the cluster as well. So that is a high level overview of the architecture. It is a pretty complex one to go. If you need to understand it in detail, you can go to DevsCube or any other resources, or even the Kubernetes official documentation, and dive deep into each of these topics like scheduler, controller manager, kubeproxy, kubelet, CRI, etc, etc. So that's it, guys. I really hope that you guys at least got a basic idea regarding what is Kubernetes and how to do things in a practical way. Please do mention in the comment section if you guys have got any queries or doubts. I'll be happy to help you. And also if you guys have got any sort of suggestions, please do mention that. I'll be happy to improve in the next video. So please do subscribe, like the video, and I'll see you guys in the next video. Bye.